Hi, welcome to the first virtual note session. As you watch, make sure you're filling in your note guide. As you do that, keep in mind that the nice to know information is going to be white, and the more important things that you want to make sure you note down are going to be in some other color. Before we begin our unit, there are a couple of things I want you to know. Astronomy is the study of space, celestial objects, and the universe, or in other words, everything outside of the Earth's atmosphere. When we say the universe, what we really mean is everything that exists, everything out there. So astronomy studies the universe. It's made up of energy, space, and matter. When we say matter, what we mean is the traditional kind of matter that we learn about in school. We got atoms made up of protons, neutrons, and electrons, and also what we consider dark matter. Dark matter is invisible, and really to have a good understanding of it, you got to have a whole lot more background in physics than anybody in this room is going to have. We're not going to cover dark matter or a form of energy called dark energy. What we will cover is a force in the universe that's called gravity. So we're going to get into gravity a lot more during the course of the semester and hopefully even have part of a unit on it. Right now, though, to start with, what you need to know is a couple of basic things about gravity. Gravity, of course, is the force that pulls all objects together. Literally all objects. So there's a force of gravity between you and your textbook. That force isn't enough to cause either one of you to move because the force of gravity to the Earth is much, much larger, but that force exists. It's the same force that pulls the moon and the Earth together, and the moon and the sun together, and the Earth and the moon, so everything is literally pulled together by gravity. The two most important things to know about gravity is what causes gravity to have a larger force. So the first one is that the more massive the objects are, the larger the force of gravity will be between them. The second thing is that the closer the two objects are, the larger the force of gravity. So of the two, distance is the much more important factor. If we take a look at Jupiter and the moon, Jupiter is much, much more massive than the moon, but the moon is much more close. So we can see the effect of the moon's gravity, which would be tides. Although there is an effect of Jupiter's gravity, it's significantly less, because of course it's much, much further than the moon. A lot of times in class, we'll talk about celestial objects. When I say that, all I really mean is a thing in space. One of the most important and notable things we'll see in space is stars. When we study stars, we study the light that comes from them. A star is a hot ball of gas that is making energy simply by taking two atoms and smushing them together. It's a process known as fusion, and stars need to be very hot and very dense to do that. There's a great variety in them, and we'll learn about what that variety tells us when we get to that unit. Also in astronomy, we'll study the solar system. When we refer to the solar system, we mean the sun and everything that orbits it. Other stars have things that orbit them, so they would have their own solar system. Within a solar system, there are planets, which are large spherical bodies that orbit the star, but aren't big enough to do fusion. There's also comets and asteroids that aren't typically round-shaped. Moons tend to orbit other objects, so moon would be something that might orbit a planet, like our moon or one of Jupiter's moons, or it could orbit a comet or an asteroid. And finally, there's other smaller bits of debris. We refer to those as meteoroids. Stars sometimes are grouped together. Our star is an isolated star, but it's within the nearest 20 light years. There's about 100 other stars. We refer to that as the stellar neighborhood. Some stars, though, are actually bound to other stars with gravity. So, for example, they might orbit each other, or there could be a whole bunch of them orbiting an area. We refer to those as star clusters. Other things in the galaxy that we'll encounter are nebulas. Nebulas are clouds of gas or dust. This is a famous one called the Pillars of Creation in the Eagle Nebula. And as many of you are probably interested in black holes. A black hole is essentially all of the matter in a star collapsed to a radius of 0. In other words, infinite density. And because light can't escape, it's black. So we can't photograph it, but we did take a picture of it with X-rays. This is a black hole we discovered in Cygnus, which is a constellation. All of these things I mentioned so far are together in a galaxy. A galaxy is a collection of millions, billions, or trillions of stars of gas and dust that are bound to each other with gravity. We are in the Milky Way galaxy. The Milky Way galaxy has about 2 billion stars. It's about 100 1,000 light years across, and it's what we call spiral shaped. And so it's got this, looks kind of like it's spinning inward. It is spinning, by the way. And we are on an outer spoke. So the main area here, it's really bright because there's so many stars here, and we're out a ways. When we look and we see the Milky Way across the sky, if you've ever been in a really dark place, you might have had a chance to see that. We're actually looking into this direction. This circle here indicates the area of our galaxy that we have the potential of finding planets, or in other words, the potential of finding something that might hold life. So when we look for aliens and things like that, we're looking in this teeny tiny part of this very large galaxy, which is only one of lots and lots of galaxies. And galaxies come in a lot of different forms. So this is the elliptical galaxy, the sombrero galaxy is. We are in our Milky Way is in a spherical galaxy, just like this one. This one's called the pinwheel galaxy. The two on the bottom are irregular shaped galaxy, meaning they don't have any specific shape to them. In this picture, each of these points of light are actually an entire galaxy. They're very, very far away, obviously. And so all of the stars we see are grouped together as just one little point of light. And so these represent groups of galaxies. Our galaxy is in what we call a local group, meaning the nearby galaxies. Ours have 46, and all of the galaxies in the universe are held together with gravity. Since astronomy has such very, very large numbers, we can deal with that with using a method known as scientific notation. You might have heard of it in previous classes, usually with small numbers. We use it with very, very large numbers. And so, for example, the Earth's mass is this very large number. Of course, that's very difficult to say, in addition to put into your calculator, that most calculators don't have that number of digits. And so instead, we write it like this: 5.972 times 10 to the 24th kilograms. So what that's essentially meaning is if we take this number and multiply it by 10 to the 24th power, we'll get this very large number. An example that's a little easier to figure out is the diameter of Pluto. The New Horizons spacecraft recently measured Pluto's diameter as 2,370 kilometers. That's easy enough to figure out, but if we wanted to write that with scientific notation, we would write it like this: 2.37 times 10 to the third. 10 to the third is essentially 10 times 10 times 10, which is 1,000. So 2.37 times 1,000 is 2,370. Essentially, that 10 to the third power tells us how many points we're going to move the decimal point over. So the decimal point was right here, and if we move it 1, 2, 3 spaces, we get our overall number, and that's why this is 10 to the third. It doesn't work that way always, but when we deal with these very large numbers, that's the way it is. In this class, we're not going to be converting back and forth between scientific notation and regular, so you don't have to worry about that. You do need to be familiar with it, so you do need to know, for example, that 6 times 10 to the 24th is a much larger number than 9 times 10 to the second. Much later in the semester, we'll also be working with these numbers in a calculator. That takes a little bit of practice. Basically, there's a special button called EXP or EE that means times 10 to them. We'll cover that much more when we get there. Just want to give you some familiarity in case those numbers come up with beforehand. Since so many of the numbers are very large, astronomers have invented some units to talk about distances in space. So for some of the distances, we'll use the units that you're familiar with. So kilometers, for example, work great for measuring the diameter of a planet. That's a number that's small enough that we can work with on a regular basis. So for example, the diameter of Pluto, as I mentioned, is 2,370. Earth's diameter is about 13,000 kilometers. But when we start trying to talk about the distance between things within the solar system, those numbers start to get really, really big. So instead, astronomers invented a unit called the astronomical unit, or AU for short. By definition, it's the average distance between the Earth and the Sun. So the Earth's distance is 1 AU. Mars is 1.52 AU from the Sun. What that essentially tells us is that Mars is 1.52 times as far from the Sun as Earth is. 1 AU is a huge distance. But when we start talking about things outside of our solar system, those distances are so large that even AU is too small. For example, our next closest star, Proxima Centauri, is 27,000 AU away from Earth. That's just the closest one. Most stars are even further than that, and so AU is too small. So another made-up distance that you've probably heard of before is called a light year, or the distance light travels in a year in a vacuum. We say a vacuum so that there's no air resistance to get in the way and slow light down. So light is about the fastest thing that we can move. The idea of talking about a distance in terms of a year is probably familiar to you. So for example, I live about 2.5 miles away from school, but I usually say, oh, I live about 7 minutes away because that's how long it takes me to get here. When I describe that, I'm not describing a time. I'm trying to describe how far I live from Earth. The same idea when we say a light year, we're talking about the distance of something. Proxima Centauri is 4.22 light years away. It's a much more manageable number to work with than 27,000 AUs. 4.22 light years away means that light emitted 4 years, 11 weeks, and 3 days ago is just now getting to Earth. The final official unit we'll talk about is a parsec, and to be honest, I'm really just throwing that out there. We're never going to talk about it again because it's fairly difficult to understand. A parsec is the distance a star must be in order for its observed parallax to be exactly 1 AU. That's really confusing. Parallax is just a way of measuring angles in order to calculate distances with trigonometry. All I care about that you know is that parsec is longer than a light year. And that's it. Finally, sometimes we don't care about the actual unit. Sometimes all we care about is how big something is compared to the Earth or the Sun. So if it's a planet, we would compare it to Earth. If it's a star, we would compare it to the Sun. Because we understand how big Earth is and how big the Sun are because they're so close to us. So Deneb is a very, very bright star that's very far away. It's so bright because it's so large. It's 3.779 times 10 to the 31st kilograms. If you remember, Earth was times 10 to the 24th, so this is way bigger. Those numbers, though, they're really kind of hard to even picture because they're so large. So we instead say that the size of Deneb is 19 solar masses. That circle with the dot inside, that just means solar mass. And what we really mean is that Deneb is 19 times as big as our sun. We do this for size, we do this for brightness, we do this for a number of measurements in space. That's it for our introduction. If you have any questions, please come see me. Hopefully we can dig into the first unit very soon.